to give the floor to Mr. Petukhov from Hexagon. Don't confuse it with Hexagon. 3 months ago I was in Las Vegas attending one of their presentations. It was so emotional. I felt like getting in my pocket and give my last dollar to them.
Thank you very much. My name is Mr. Petukhov. I'm responsible for the sales department of Leica Gala System and imaging, which is at the moment the division of Hexagon company. In fact, this is my third presentation. It's good that it's becoming a tradition. The day before yesterday, during the quiz, I remember if I put something from ZT and Leica Geosystems, we already participated in this conference 5 times, so we could had the right to a tough question. Number one, first I have to apologize. Perhaps my presentation is not polished enough because at Hexagon we generate so many new technologies and products that even locally we are not aware of all of them and do not really understand what is going on around us in our company. I will tell you very fast and briefly and in outlines what we have now among our most recent sensors, and I would like to concentrate on the technology of automated generation of 3D models of the cities based on the most recent project for Zurich. Until recently, the toughest question for me was when I was asked what company you're working at. As a result of all these mergers and acquisitions, we have Intergraph, ZT Imaging, we have Hexagon, Leica Imaging, and all of this was moving from one to another, but finally it all settled down, and now we work in a single thing called Hexagon Geospatial Solutions Division. That's where all aerial imaging technologies and equipment are concentrated. Should I press this button? Oops. You said that wasn't Hexagon, right? Oh, anyway, our headquarters are located in Airborne, Switzerland. That's where Leica Geosystems are. That's where our production center is. The second production center is still remains in Allen. In Airborne, we'll concentrate the development and manufacturing of the so-called linear sensors, like ADS cameras and laser scanners. As far as the frame sensors are concerned, they will be done by Zeta Imaging. That's where they're going to generate and manufacture ZT-30 cameras. It's a very good positioning. It takes just a bit more than 2 hours by car, and that's why our developers meet on a regular basis. And after all of these mergers and reorganizations, now we have an interpenetration process between different technologies from different sensors. All of them are concentrated in different things. And after this merger, Hexagon has the fullest line of different types of sensors. We have large format cameras like linear sensor ADS, frame sensors DMC, mid format camera CD30, and line of laser cameras ALS 70. Very briefly, I will talk about new products that we saw most recently. First, it's our new camera ADS 100, which is already on the market, and we sold a couple of them already, and we received very positive feedback about the quality of this camera and the imaging acquired by it. The main difference from previous generation of ADS 80 is larger coverage, which increases the productivity by about 60%. The second model. It's not a model, it's more like an intermodel of DMC2E, extended in this case. It's different from the previous DMC2 cameras in that the console computer, which originally was like an autonomous module installed on the craft, now it is fully integrated into the camera. And as a result, there are less number of connections, greater reliability and readiness time. And we applied Novotel spam, and all electronics are located also inside this camera. Another important thing is that now we are unifying all these components. And for instance, DMC cameras at the moment are using same disks for image storing, like in all other sensors, ADS, LS, and RCD30. More details about our new camera, ADS-100. This is the delivery package. You get the camera itself, managing computer, and the operator's monitor and pilot's monitor. Here you can see the principal parameters. The main idea of image generation is the same as for ADS-80. So it's like three cameras, one looking in front, one in nadir, and one back. And each camera has 20,000 pixels and a number of lines, spectral and infrared band. Unlike ADS-80 camera, we don't have panchromatic channel because all spectral channels have the highest resolution. So all of them have 20,000 pixel resolution. The nadir camera also has additional line in the green channel, which is shifted half a pixel size from one to another, which provides us to helps us to implement the so-called HD resolution after interpolation. We have not 20,000 pixels, but 40,000 pixels. Of course, it's not a fully 40,000 pixel resolution because of the interpolation. The actual resolution would be lower, but more than simply 20,000. Another difference is that the camera, ADS camera, has electronic shift compensation. These lines here of all three cameras, in fact, are not lines, but more like a combination of 16 lines, which helps us to implement the electronic shift compensation mode. We have different modes from 1 to 15 pixels shift compensation, which helps us to fly at greater speeds with worse lighting conditions, because with electronic shift compensation we accumulate charge early. In the ADS-80 it was a problematic part because of the difficulties with light, especially over some Russian territory. Now this problem has been almost fully resolved. Now about parameters, the dynamic range, 14-bit depth, and other parameters. For comparison's sake, here you can see a picture which shows the swath for ADS-80 and the ADS-100. For ADS-100, from 1,254 meters with 10 pixel resolution, we have 2 kilometer swath of capture. Speaking about DMC, the new model DMC2E is also available in this configuration of DMC2 240, 230, 250. 230, 240, and 250 would be the size of sensor in megapixels. Here you can see the parameters and sizes and number of lines and pixels. The biggest at the moment sensor is 17,216 by 14,656 pixels. Often we're asked which camera is better, ADS or DMC. And to answer your question preventively, I can tell you that looking at it from application point of view, where we can apply DMC or ADS cameras, to a certain extent there is an overlap, especially after advent of ADS-100. Still, these cameras have their own specifics which allow them to be used with greater efficiency for different applications and projects. Like I told you, ADS camera has same resolution of all spectral channels, and there is no need to do pen sharpening. Whereas in DMC, the panchromatic channel is of high resolution, which is colored by spectral channels of lower resolution. In ADS, all the channels have same resolution. That's why there are no losses, which is an ideal situation or mode for different projects requiring spectral classification. Also, I told you that with the application of electronic shift compensation, ADS camera can already fly at lower heights with greater speeds, but still DMC is better than that because whereas in ADS the depth of compensation is 16 pixels, in DMC camera the shift compensation is more than 100 pixels, which helps them to fly with very bad lighting conditions, with very low sun angles and high speeds also. That's why if we speak about the most efficient application, I would say that ADS 100 is the camera which is very good for highly productive process of developing of orthophotos, because the camera is generates not separate frames but the whole carpets or blankets of images with the minimization of the seams and very efficient post-processing. But on the average we can assess that the time for imaging or the time taken for orthophoto plans is equal to the time of flyby. If it takes to fly 2 hours, in about 2 hours time you get your orthophoto. Speaking about DMC, if we speak about engineering projects with high resolution on the bad lighting conditions requiring stereo processing, then DMC camera is your device. These are examples taken at night at 1929. The sun is under the horizon. This is the artificial lighting on the stadium. You have 1 more minute. Okay. Here you can see an example of how good is this camera, how it works well under bad lighting conditions. It is one of the most popular cameras on the market. I'm talking about LS70. We're continuing to improve it. Also, we have a oblique imaging camera, 3 options, and 3 and 4 camera solution. Here you can see images what it looks like. These are the angles of capture, different examples of images, and here you can see unification of the whole onboard structure. Any sensor can be used with the same infrastructure. Our drone, our Swiss drone as we call it, with ACD30 mounted on it, and this is one of the few options when the camera is mounted on a UAV. You can see the parameters, see also some of the results of imaging, like here 3 centimeter resolution, very good geometry, and these are the results of building a very dense cloud of points. Also in our portfolio now we have a lower class UAV, but I don't have any more time to tell you about it. Thank you, Mikhail. You see, Reisman made a presentation already. Many people wanted to buy his camera. Now Hexagon make a presentation and we want to buy 2 more. Why didn't they invite Vichard? I'm talking about everybody here. Victor, why didn't you invite Vichard? Then you would confuse everybody here from Vexel Imaging. Anyway, other questions or comments? So who needs more pixels per square kilometer? Raise your hands. Mikhail, you had a very good report. Please participate in all our activities. He will be staying with us and we'll be able to ask him any questions. Thank you. Простите, можно задать вопрос? Макс Тейлор. Air говорит, нам всегда нужно больше пикселей.
And I think everybody is going to move to the more pixels they can get. But at the same time, just one comment, of course, there is a problem between getting more pixels and keeping your buildings from having too much lean on them. And this is something you can all see if you look at the Bing maps, for example. Not always satisfactory. Thank you.
Спасибо. Ну, это вопрос конкретного проекта и конкретных технических.
That was a question for specific projects and specific technical specs and requirements. Like Zurich project, for instance, was the project which we made with a resolution of 6 centimeters. We used our oblique imaging devices. We built vectorized models of buildings. We texturized them. You can see these vectorized buildings, and these are textures. And we had a lot of data, but still we managed to put it together quite quickly using modern computer power. Everything boils down to this. Anyway, in this software 3D Core, we have 2 modes. One mode, full resolution mode, which requires more time, but there's also an opportunity for you to go for lower geometrical accuracy and to get a lower quality or lower accurate model. So there is a flexibility input there. My heart is still bleeding. I cannot put a stop to you like previous speaker, but we have many other speakers ahead of us, but we have only one dinner.
И, конечно же,